Mitsubishi. Welcome back to our classroom. Today, I'll be teaching you about acids and alkalis. What are acids? Acids are substances that produce hydrogen ions when dissolved in water. These hydrogen ions are responsible for the characteristic properties of acids. For example, hydrochloric acid, HCl, sulfuric acid, H2SO4, nitric acid, HNO3. Now I'll teach you some properties of acids. They taste sour, well, the ones that you can eat. For example, lemon juice. But never taste any chemicals in the lab. They feel corrosive. They can burn skin and damage materials. A less strong acid, like lemon juice. The effect on universal indicators are they turn blue litmus paper red. The pH is less than 7. The lower the pH, the stronger the acid. For example, lemon juice isn't as strong as the strongest pH would be. The conductivity is that they conduct electricity when they're dissolved in water, but most of them don't otherwise. Strong acids fully ionize in water, meaning all acid molecules dissociate to release H+ ions. For example, hydrochloric acid, nitric acid, and sulfuric acid. Some weak acids partially ionize in water, meaning only a small fraction of acid molecules dissociate. For example, ethanoic acid, CH3COOH. Carbonic acid, H2CO3. What are alkalis? Well, alkalis are soluble bases that produce hydroxide ions, OH negative, when dissolved in water. These OH negative ions are responsible for the characteristic properties of alkalis. For example, sodium hydroxide, NaOH, potassium hydroxide, KOH, and ammonia, NH3. Now, alkalis and bases are slightly different. Bases are just substances that have a pH that is higher than 7. But alkalis are inside the group of bases, but are only the ones that are soluble. Now, I'll teach you some property of alkalis. They taste bitter, the ones that you can eat. But remember, never eat chemicals that are in a lab. They feel soapy or slippery. They also feel corrosive. The effect on indicators are they turn red litmus paper blue. They have a pH that is greater than 7. The higher the pH, the stronger the alkali. They conduct electricity when they are dissolved in water. Bases are chemical compounds that can neutralize acids. They are typically metal oxides or metal hydroxides. Alkalis are a specific type of base that is soluble in water. An important note is all alkalis are bases, but not all bases are alkalis. For example, copper 2 oxide is a base, but not an alkali because it's not soluble in water. The definition of a pH scale is a numeric scale, 0 to 14, that is used to express the acidity or alkalinity of a solution. It measures the concentration of hydrogen ions in a solution. pH 7 means it's absolutely neutral, for example, pure water. A pH that is less than 7 is acidic. The lower the pH, the stronger the acid. If the pH is above 7, it means it is a base or is basic or alkaline. The higher the pH means the stronger the alkali. Acid-base indicators are substances that change color depending on the pH of the solution that they are added to. They are often used to determine if a solution is acidic, alkaline, or neutral. Some common indicators are litmus. They are red in acid, blue in alkali, and purple in neutral. Or methyl orange. They are red in acid, yellow in alkali, and orange in neutral. Phenolphthalein. They are colorless in acid and pink in alkali. A universal indicator. It's a mixture of indicators showing a range of colors across the pH scale. Acids are highly reactive and participate in several important chemical reactions. These reactions typically produce a salt, which is an ionic compound formed from the reaction of an acid with a base, metal, or carbonate. We will explore three main types of reactions. The first reaction is an acid and metal reaction. The general equation is, which is the equation that you can just fill in the blanks for, is an acid plus the reactive metal is the salt plus hydrogen gas. The conditions you need is the metal must be more reactive than hydrogen, for example, magnesium, zinc, iron, but not copper or silver because they are less reactive. The observation you should have is effervescence, which is just a fancy word for fizzing, due to the production of hydrogen gas. The test to see if it is hydrogen is holding a splint that is on fire at the mouth of a test tube which contains the gas that you suspect is hydrogen, and if it produces a squeaky pop sound, then it is hydrogen gas. Some examples of an acid-metal reaction is hydrochloric acid plus magnesium, which is 2HCl plus magnesium becomes magnesium chloride plus hydrogen. Magnesium chloride is the salt that is created. Sulfuric acid plus zinc, H2SO4, which is sulfuric acid, plus Zn, which is zinc, becomes zinc sulfate, which is aqueous, plus hydrogen gas. Zinc sulfate is the salt. Nitric acid plus iron. Nitric acid, 2HNO3, which is nitric acid, plus Fe, which is iron, becomes FeNO3, which is iron 2 nitrate, plus hydrogen gas again. Iron 2 nitrate is the salt. The second type of reaction is an acid and a base, which is called neutralization. The general equation for this is the acid plus the base becomes the salt plus water. The definition is neutralization is a chemical reaction in which an acid and a base react to form a salt and water, and the product should be neutral. The H plus ions from the acid combine with the OH negative ions from the base to form water. H plus OH becomes H2O because there's one O and two H. Some bases include metal oxides and metal hydroxide, alkalis. Now I'll give you some examples for an acid plus metal oxide reaction. Hydrochloric acid plus copper 2 oxide. 2HCl, which is aqueous, plus CuO, which is copper, and a solid, becomes CuCl plus H2O. Copper 2 chloride is the salt. Sulfuric acid plus magnesium oxide. H2SO4 plus MgO becomes MgSO4 plus H2O. Magnesium sulfate is the salt. Now I'll give you some examples of an acid plus metal hydroxide reaction. Metal hydroxide is an alkali, and so was the metal oxides. Hydrochloric acid plus sodium hydroxide. HCl, which is aqueous, plus NaOH, which is aqueous, becomes NaCl, which is aqueous, plus H2O. Sodium chloride is the salt. Sulfuric acid plus potassium hydroxide. H2SO4, which is aqueous, plus 2KOH, which is aqueous, becomes K2SO4, which is aqueous, plus 2H2O, and which is a liquid. Potassium sulfate is the salt. Now, I'll tell you about acid plus carbonate reactions. The general equation is acid plus carbonate becomes salt plus water plus carbon dioxide. The observation you should have is that there's a strong effervescence, which again is just a fancier word for fizzing, due to the production of carbon dioxide gas. The test for carbon dioxide is bubbling the gas through lime water, which is just calcium hydroxide solution, and if it turns cloudy or a milky kind of thing, then the gas that you just bubbled through the lime water is carbon dioxide. Some examples of acid plus carbonate reactions are hydrochloric acid plus calcium carbonate. 2HCl, which is aqueous, plus CaCO3, which is a solid, becomes CaCl2, which is aqueous, plus H2O, which is a liquid, plus CO2 gas, and calcium chloride, which is CaCl2, is the salt. Sulfuric acid plus sodium carbonate. H2SO4, which is aqueous, plus Na2CO3, which is a solid, becomes Na2SO4, which is aqueous, plus H2O, which is a liquid, plus CO2 gas. Sodium sulfate, which is Na2SO4, is the salt. Now, the names of salts depend on the acid used and the metal or ammonium ion in the base or metal or carbonate. For example, hydrochloric acid produces chlorides, sulfuric acid produces sulfates, nitric acid produces nitrates, and ethanoic acid produces ethanoates or acetates. Now, I'll give you a few questions to test how well you understood. Number 1. Write the word equation and balance the chemical equation for the reaction between nitric acid and zinc. Number 2. How would you test for the gas produced when sulfuric acid reacts with magnesium? Number 3. A solution turns red litmus blue. What can you say about its pH? Number 4. What are the products of the reaction between hydrochloric acid and potassium carbonate? Number 5. Define the term alkali and give one example. Number 1. The answer is, the word equation is nitric acid plus zinc becomes zinc nitrate plus hydrogen. The chemical equation, however, is 2HNO3, which is aqueous, plus Zn, which is a solid, becomes ZnNO3, 2, which is aqueous, plus H2, which is a gas. The answer for number 2 is the test for hydrogen gas is holding a splint that is on fire at the mouth of the test tube with the gas inside it. A squeaky pop sound confirms that it is hydrogen. Any other sound, or if there is no sound at all, it's not hydrogen. The answer to number 3 is the solution is alkaline, so its pH must be greater than 7. The answer to number 4 is potassium chloride, water, and carbon dioxide. The answer to number 5 is an alkali, is a soluble base that produces hydroxide ions, OH-, when dissolved in water. For example, sodium hydroxide, NaOH. Now, you might be thinking that you don't see any acids or alkalis in your day-to-day life, but you'd be wrong. Here are some acids and alkalis that you use in your day-to-day life. For acids, you must use vinegar for cooking and cleaning. Hydrochloric acid is in your stomach for digestion, and sulfuric acid is in car batteries. For alkalis, sodium hydroxide is caustic soda for making soap and cleaning products. So if you use any kind of cleaning product, then you're using an alkali. Ammonium hydroxide, is used in household cleaners. Calcium hydroxide, lime water, is used for neutralizing acidic soil. Some safety precautions you should use is that acids and concentrated alkalis are corrosive, so always handle with care. Wear appropriate personal protective equipment, also known as PPE. For example, safety goggles to protect your eyes, a lab coat to protect your normal clothing and your skin, gloves to protect your hands, and in case of spills, follow the lab safety procedures. Dilute concentrated acids by adding acid slowly to water. Never ever add the water to the acid. You have to add the acid into the water, not the other way around. The summary of today's lesson is acids produce H positive ions, alkalis produce OH negative ions in water. The pH scale indicates acidity or alkalinity, which is 0 to 14. The indicators show pH changes by color. Acids react with reactive metals, becomes salt plus hydrogen. Bases, for example, metal oxides or hydroxides, becomes salt plus water, which is called neutralization. Carbonates are salt plus water plus carbon dioxide. Thank you for watching this video, and please like and subscribe if you learned something new. 3, 2, 1.